Soalan 1A PYQ. Okay, first question, define stress and strain. Okay, stress stress ialah the ratio of the perpendicular force to the cross sectional area, and then strain the ratio of extension to the original length. Okay, and then second question, what is meant by plastic deformation? So in short term ialah when a material is deformed beyond its elastic limit. Okay. And then question number 3, sketch a label graph of stress against strain showing the elastic and plastic deformation regions for a ductile metal under tension. Okay, first draw from original point to A, then A to B, and then B to C, and then C to D, and lastly D to E. So we can see that from original to B is elastic deformation, and then from C to E is plastic deformation. Okay, thank you.
Okay, question 1B. A 20 kg mass is hung from a 2 meter long vertical wire. If the wire is elongated by 3 millimeters, calculate the strain energy stored in the wire. So we know the strain energy is given by the formula U equals to half Fe. F is the force that is acting on the wire and E is the elongation of the wire. So elongation is given by the question here. Wire is elongated by 3 millimeters. We convert millimeters to meters. We will get 3 times 10 to the power of negative 3 meters. That's for the E value. Okay, let's check. And then for F, F is the weight force that's acting on the wire provided by the 20 kg mass. So for weight, we know is mass times gravitational acceleration. So we simply key in the values that are given by the question into the formula. Half times the weight force, which is the mass times the gravitational acceleration, times E, which is 3 times 10 to the power of negative 3. Calculate that, we will get 0.2943 joules. Joules because it's energy.
To A, define Young modulus. So Young modulus is the ratio of stress to strain if the proportionality limit has not been exceeded. For B, sketch a level stress strain graph of a ductile material. Stress and strain from origin to point B is elastic deformation, and from C onward is plastic deformation.
So for question 2C, the question is, a wire fixed to a ceiling has a length of 1.5 meter and cross-sectional area 0.2 cm squared. The wire stretches by 0.15 cm when a 50 kg load is attached to its free end. Calculate the Young modulus of the wire. To calculate the Young modulus of the wire, first we need to find the stress, and strain. So from the question, we have the information. The mass is 50 kg, the IO is 1.5 meter, E equals to 1.5 times with 10 power to negative 3, and the area is 0.2 times with 10 power of negative 4 meter squared. So first, we need to find the stress, which is, the formula is F over A, which we know the F is equal to mg over A. So 50 times with 9.81 divided with 0.2 times 10 negative 4 until we get 2.45 times with negative power of 7 Newton meter per negative 2. Then we find the strain, which is, the formula is E over 2IO. Then we 1.5 times with 10 negative 3 divide with 1.5 meter, which we can get 1 times with 10 power of negative 3. After we get the stress and strain, then we include to the formula Young modulus, which is Young modulus is equal to stress over strain. So 2.5 times with 10 power of 7 divided with 1 times with 10 negative 3, then we get the final answer, which is 2.5 times with 10.
Question number 3, figure 11.1 shows an illegal force F acting onto illegal rods by made of different materials. What concept will be used to determine which rod will be more? Explain your answer. My answer is use Young modulus concept to determine which rod will bear more. This is because the greater Young modulus of material, the straighter the rod and it requires more energy to bend the rod.
4B, a wire of diameter 0.5 mm has Young's modulus 2 darab 10 kuasa 11 Newton meter. Calculate the strain if it is extended by 150 Newton load. Okay, so kita keluarkan maklumat dia dulu. F equal to 150 Newton, D dia 0.5 mm. Kita nak dapatkan R, kita bahagikan D dia 0.5 bahagi dengan 2, kita akan dapat 0.25 mm. Kita tukarkan nilai R dia kepada meter, kita akan dapat 2.5 times 10 kuasa negatif 4. Jadi untuk cari A, kita guna formula pi R square. Pi 2.5 times 10 kuasa negatif 4 square, kita akan dapat 1.96 times 10 kuasa negatif 3 meter square. Yang modulus dibagi 2 darab 10 kuasa 11 Newton meter negatif 2. Kita nak cari strain, jadi kita guna formula stress equal to F over A. Kita akan dapat 7.653 darab 10 kuasa 4. Untuk dapat strain tadi, kita guna formula Young modulus. Kita akan dapat 3.827 times 10 kuasa negatif 7.
Why Hooke's law is not applicable in the case of plastic deformation? Hooke's law is not applicable in the case of plastic deformation because when a material undergoes plastic deformation, a strain hardening followed by necking, finally fractured occur. During strain hardening, atomic planes slip past one another due to movement of atomic dislocations. At the yield point, necking occurs when the material becomes narrow and the material cannot return to its original shape after the stress is removed. Hooke's law is not applicable beyond yield point because the intermolecular forces are too weak to resist the applied force and the material can break easily. Thank you.
Soalan ni dia cakap a 50 cm wire has Young's modulus 175 gigapascal and diameter 0.25 mm. Calculate the force needed to elongate the wire 1.5 mm. So first kita keluarkan semua information yang dia bagi. So first dia bagi initial length, which is 50 cm. Tukarkan kepada meter, dapat 0.5 meter. And then dia bagi kita yang modulus dia 175 gigapascal. So dia tukar jadi 175 darab 10 power of 9 pascal. And then dia bagi tahu diameter dia. Diameter which is D equal to 0.25 mm. Kepada meter akan dapat 2.5 times 10 negatif 4 mm. And then from diameter kita boleh dapat R. So R dia equal to bagi 2 je lah. So 1.25 darab 10 negatif 4 meter. And then from radius kita boleh dapatkan area dia. So area equal to pi R square. Masukkan R 1.25 darab 10 negatif 4 square. Kita akan dapat
4.909 darab 10 negatif lah meter square. And then dia bagi tahu the force needed to elongate the wire 1.5 mm. So maksudnya extension dia adalah, so E dia adalah 1.5 mm. So kepada meter akan dapat 1.5 times 10 kuasa negatif 3 meter. Okay, so semua information dah ada. So dia nak force, dia bagi yang modulus. So kita boleh pakai formula yang modulus terus lah. Yang modulus equal to tensile stress over dengan tensile strain, sama dengan tensile stress adalah F over A area, force over area. So bagikan dengan tensile strain adalah extension over pula dengan initial length. So at the end dia punya formula adalah F times initial length over dengan area times extension. So sama lah Y F times initial length over area times extension. So kita boleh masukkan info tadi. Y dia 175 times 10 of 9 Pascal, sama dengan F dia yang kita nak cari, and then initial length dia adalah 0.5 meter over dengan area dia adalah 4.909 times 10 negative 8, dan times dengan dia punya extension 1.5 darab 10 negatif 3 meter. Allah, divide lah ni. So akan dapat, kita substitute ni, dah substitute, kita tekan calculator and then pindahkanlah F ni kat tepi ni. So nanti at the end akan dapat jawapan dia 25.8 Newton force dia. Itulah final answer dia.
Fast year question number 6. A solid of cylinder 10 meter high and 10 cm in diameter is compressed by a 1.105 kg load. Calculate the strain energy stored in the cylinder. The Young modulus of cylinder is 1.9 times 10 power 11 Pascal. So we know the length of the cylinder is 10 meter, the diameter is in 10 centimeter, so we change it to meter, 0.1 meter, and the mass is 1 times 10 5 kg. The Young modulus is 1.9 times 10 11 Pascal. So we use the Young modulus formula, which is Y equals to FL over AE. From that we can get the area of the cylinder. So we get we sub the information so that we get 7.85 times 10 power negative 3 meter. So we use again the formula to find the E. So we sub the information that we get. That's how we get E equals to 6.577 times 10 negative 3. Now we get the E, we can sub into the strain energy formula, which is U equals to 1 over 2 FE. FE could also be mg, so that's why we sub the equation. We get the final answer is 3226 joule.
Okay, soalan PSPM 2017-2018 nombor 7. A 20 cm cylinder breastroot with diameter 6 cm is held vertically on its one circular flat end. A load of 5 kg is placed on its upper end. Given the Young's modulus of press is 9.1 times 10 power of 10 Newton per meter square, calculate the strain energy of the rod.
So from the question, dia dah bagi nilai length which is 20 cm, and then kita convertkan dalam meter. So dia bagi juga diameter which is 6 cm, kita convert dalam meter juga. And then dia bagi mass 5 kg and nilai Y 9.1 darab 10 kuasa 10 Newton per meter square. So kita akan guna formula Y sama dengan FL over AE. Berdasarkan maklumat ni, dia dah bagi nilai Y dengan dia dah bagi nilai L. Dia tak bagi nilai F, AE. Tapi berdasarkan maklumat ni, kita boleh cari nilai F dengan nilai E. So first kali nak cari nilai F, kita tahu F sama dengan W sama dengan mg. So kita just substitute sebab kita dah ada nilai M, and G is 9.81 which is gravity. So just substitute 5 darab 9.81, kita dapat 49.05 Newton. Next kita nak cari nilai A pula. A sama dengan, kita guna formula pi d kuasa 2 over 4. So kita dah ada nilai diameter, just substitute, and then kita dapat 2.83 darab 10 kuasa negatif 3 M kuasa 2. So kita dah ada semua nilai Y, F, L, A kecuali E. So just substitute dalam formula untuk dapat nilai E. Just substitute 9.1 darab 10 kuasa 10 sama dengan 49.05 darab 20 darab 10 kuasa negatif 2 per 2.83 darab 10 kuasa negatif 3E. And then selesaikan, kita dapat E sama dengan 3.809 darab 10 kuasa negatif 8M. And then soalan dia nak kita calculate the strain energy of the rod. So formula the strain energy of the rod is U sama dengan 1/2 Fe. So since kita dah ada nilai F, kita dah ada nilai E, just substitute 1/2 darab 49.05 darab 3.809 darab 10 kuasa negatif 8, and then kita dapat the final answer which is 9.34 darab 10 kuasa negatif 7 Joule. Question 8. An aluminium wire, initially 2.45 meter long and diameter of 1.5 mm, is suspended from rigid support with a load of 15 kg attached to its lower end. Young's modulus of aluminium is 7.0 times 10 power of 10 Newton meter power of -2. Calculate the A extension of the wire. So the first step we need to do is we need to take out the information. So we know that this is initial length, or we call it as L naught. So L naught is 2.45 meter. We write it here, and then the diameter is 1.5 millimeter. Then we need to change it to meter, so we need to times by 10 power of -3. And then it said the load is 15 kilogram. So we write it M equals to 15 kilogram. Then the Young modulus of aluminium is 7.0 times 10 power of 10 Newton meter per -2. And then first we need to find the force. From this case, we need to find force by using the formula W equals to mg. So we know that the mass is 15 and the G is 9.81. So we just simply times, we got 147.15 Newton. And then we need to find the area. So we use the formula pi d square over 4. And then we insert the value of D, which is 1.5 times 10 power of -3 into here, and then we solve. We got 5.625 times 10 power of -7 pi meter square. And after we got the area, we need to use Young's modulus formula to find the extension of the wire. So the formula of Young's modulus is equals to force times L naught over area times extension. So we put the Young modulus of the aluminium, which is 7.0 times 10 power of 10 equals to the we insert the value of F. We got initially from the calculation, and then we times by L naught over area we got here, and then we need to times by extension, which we need to find the value, and then we solve and we got the extension of the wire is 2.914 times 10 power of -3 meter. So next, the question asks the strain energy stored in the wire. So we need to use the formula of strain energy equals to 1/2 force times extension. And then we got the value of the force here, 147.15, and then we just simply times by the extension we got from A. So 1/2 times force times extension, we will get 0.2144 joule.
Untuk nombor 9, the diameter of circular shoe heel is 13 mm. If both heels support 70% of the weight of a 54 kg woman, calculate stress on both heels. Untuk dia punya penyelesaian, kita keluarkan apa yang dibagi dekat soalan, iaitu dia bagi tahu diameter adalah sama dengan 13 darab 10 kuasa -3 meter. Kita dah tukar yang mm tadi kepada meter. Lepas tu daripada diameter kita akan dapat cari radius dia, iaitu kita bahagi je dengan 2. Dapat 6.5 darab 10 kuasa -3. Lepas tu dia punya mass adalah 54 kg. Untuk cari F, kita masukkan dalam rumus mg. Lepas tu kita darabkan dengan 70 per 100 sebab tadi dia beritahu 70%. So akan dapat nilai 370.818 Newton. Untuk cari stress, rumus dia adalah F sama dengan 2A. A itu sama dengan pi R kuasa 2. Kita sub je nilai. So semua akan dapat 1.395 darab 10 kuasa 6 Newton per meter square.
First question is, figure 12.1 shows a 10 kg weight suspended by a 0.2 meter vertical copper wire with cross-sectional area 5 mm per square. A 5 kg is suspended by a similar wire from the bottom of the 10 kg weight. Calculate the strain of each wire. The Young modulus of copper given is 1.1 multiple 10 power of 11 and m negative 2. Calculate the strain of each wire. So kalau kita cari strain, kita boleh menggunakan formula Y equals to stress divided by strain. So Y dia diberi adalah 1.1 darab 10 kuasa 11 and m negatif 2. Dan kita hanya perlu mencari stress. Disebabkan dia ada dua jenis, so kita kena cari untuk M yang pertama, iaitu M equals to 5 kg. Okay, kita boleh mencari F sebabkan dia ada tension dan dia ada mg. Saya tergantung macam ni kan. So kita boleh cari F dan A diberi adalah 5 darab kuasa negatif 6 meter kuasa 2. Dan kita kira sahaja, kita mendapat stresnya adalah 9.81 darab 10 kuasa 6 nm negatif 2. Maka jika kita mendapat stress, kita boleh mencari strain. So strain equals to stress per Y. So 9.81 darab dengan 10 kuasa 6 per dengan 1.1 darab 10 kuasa 11, dia dapat 8.91 darab 10 negatif 5. So yang kedua, kita perlu mencari M yang kedua, iaitu 10 kg. So kalau kita mencari tension F untuk M yang kedua ni, dia lain sikit sebab dia ada tension, dia ada weight, dan dia juga ada tension untuk yang ni juga. So maka tension equals to weight plus
tension 1, dan kita kira 10 kg darab dengan ni mg, 10 darab dengan 9.81 tambah dengan tension tadi, kita mendapat 147.15 Newton. Dan jika kita dapat tension, kita boleh mencari stress dengan menggunakan formula sama, F per A. Kita dapat 147.15 bahagi dengan 5 darab 10 negatif 3, kita mendapat 2.943 darab 10 kuasa 7 Nm negatif 2. Dan kita dapat stress, kita boleh mencari strain. Kita bagi saja dengan yang stress bahagi dengan yang modulus tadi, kita mendapat 2.67 darab 10 negatif 4. Itu saja, tiada unit. Okey, soalan kedua adalah the extension of each wire. So extension, dia punya formula adalah, ikutkan formulanya adalah strain equals to extension per dengan initial length. So kalau kita cari extension, dia tukar menjadi extension equals to strain darab dengan initial length. So kita gantikan saja, kita sudah dapat pun jawapan untuk strain for each wire. Kita masukkan saja untuk darab dengan initial length, iaitu 0.2 meter, dan kita darab, kita mendapat 1.78 darab 10 negatif 5 meter. Dan untuk yang strain kedua, untuk extension yang kedua, kita masukkan je formula macam atas ni, strain darab dengan initial length, kita mendapat 5.34 darab 10 negatif 5 meter. Itu saja. Sekian.
Okay, question number 3. A 4.0 meter iron rod with cross-sectional area 0.5 cm second extends by 1.0 mm when a 225 kg mass is suspended from one of its ends. Calculate the A, Young's modulus of the rod, B, elastic energy stored in the rod. Okay, so daripada question kita dapat length original sama dengan 4.0 meter. Kita dapat cross-sectional area A 0.5 cm second, so kita tukarkan daripada meter second. Kita dapat 5.0 darab 10 kuasa negatif 5. So kita dapat extension produce 1.0 mm, kita tukarkan jadi meter, so kita dapat 1.0 darab 10 kuasa negatif 3 meter. And then kita dapat mass sama dengan 225 kg. So A yang modulus of the rod, so kita kena guna formula Y sama dengan F L original over AE. So first kita kena cari nilai F. Kita guna formula F sama dengan mg. So masukkan nilai M dan G. So 225 darab 9.81, kita dapat 2.21 eksponen 3 Newton. So kita masukkan nilai F, length original A dan E dalam formula Y tadi. So kita dapat 1.77 darab 10 kuasa 11 Newton per meter second. So B, elastic energy stored in the rod. So kita kena cari energy. So kita guna formula W sama dengan half FE. So masukkan nilai F tadi dan E. So kita dapat 1.10 joule.
A very good morning. Okay, today I'll be discussing about question 5A from additional chapter 11 physics. So let's read the question first. A 20.0 kg of mass is hung from a 2.0 meter long vertical wire. So let's say 20.0 kg from a 20 meter long wire. If the wire is elongated by 3.0 millimeter, calculate the strain energy stored. Okay, so the mass. Take out the mass, the information. 20.0 kilogram. The initial length is 2.0 meter. The final length is 2 plus with 3 times 10 power negative 3 meter. Because why? Because the initial is 2 and the wire is elongated to 3 by 3. So you need to plus with 3 times 10 power negative 3. Change the 3.0 millimeter to 3 times 10 power negative 3. Then you will get 2.003 meter. Okay, strain energy stored is same as the work done by the wire. So the formula is energy stored, which is U is equal to 1/2 Fe. So this is the formula for strain energy stored. So first you need to find E, where E is the elongation. Formula is final length minus with initial length, and force, and the force is the force acting, which is the mass, and the force we use here is weight, which is equal to mg. So all the informations are taken out in the formula. So now we can find the elongation first. So elongation equal to 2.003 minus by 2. Then you will get 3.3 times by 10 power of negative 3 meter. And the force also can be found. Force is equal to mg. Force is equal to weight. Thus weight equal to mg, and 20.0 times by 981. Okay, so then you will get 196.2 Newton. Okay, then we're moving on to the formula, where U equal to 1/2 Fe, 1/2 times by the force 196.2, and the elongation 3 times 10 power of negative 3. Then you will get 0.2943 joule. So the unit is in joule because it is asking us to find the energy. So here you go. Thank you for watching.
5B. 1. Define stress and strain. Stress is defined as the ratio of the perpendicular force F to the cross-sectional area A, and strain is defined as the ratio of extension elongation E to origin length. 2. What is meant by plastic deformation? Plastic deformation occurs when a material is deformed beyond its elastic limits. 3. Sketch a level graph of strains against strain showing the elastic and plastic deformation regions for a ductile metal under tension. So the graph is stress against strain. From 0 to B point it is a elastic deformation, and from C point to E point is a plastic deformation.